Welcome to the Agent RCS demonstration video. Agent RCS was developed by 21st Century Systems during a Phase 1 SBIR contract with the National Institute of Standards and Technology. The purpose of this video is to highlight the features of Agent RCS through a demonstration scenario which utilizes many of the capabilities of Agent RCS. We will begin by giving a general overview of the application and its UI. Agent RCS was developed using the Eclipse RCP plugin architecture and is built on top of 21st Century Systems' own Edge framework, which provides much of Agent RCS's functionality such as the map and its multiple layers and agent frameworks, just to name a few. The Eclipse RCP architecture, while providing a standard Windows look and feel, also provides many of the main components of the default UI seen here, such as the flyout panel on the right, which contains a multiple vehicle status display. The RCP architecture also gives quick and easy access to standard functionalities such as menus, pop-ups, and the ability to open additional views within the application. The buttons on the left side of the map are provided by the Edge framework and give the ability to control scrolling and zooming of the map, as well as the ability to add waypoints and routes to the map, along with areas of interest or AOIs. The core of our application is built around the ability to control robots as they move around a simulated environment within the Unreal Tournament game engine. To accommodate the needs of the system, we built a command control structure which resides within every controllable object inside the Unreal Arena. The command control structure gives us the ability to queue multiple commands for execution instead of only allowing one command at a time to be processed. As seen here, the vehicle is being assigned to a route which contains 3 waypoints. These 3 waypoints are queued within the robot's command structure as a route command. As the vehicle approaches its first waypoint, you can see that the completed command is removed from the queue and the robot is now given its next command. To allow for a higher level of control, we implemented a multi-resolutional cost map structure into our application. This cost map is an internal representation of prior knowledge about the arena which is currently being used. The cost map allows for section-level agents to intelligently give routing information to the vehicles within the arena. The multi-resolutional aspect of the cost map allows for agents at different levels of control to see information that is pertinent to their level of detail. In short, the lower your level of control, the higher the resolution required to accomplish your goal. To accommodate for different types of situations within our scenarios, we have implemented many different types of ways to control the vehicles within the arena. Vehicles can be instructed to drive directly to a point on the map, given a series of points to a location as determined by the underlying cost map information, or given a series of user-selected waypoints to drive along. Along with these, a vehicle can also be commanded to drive to an AOI and search it, once again utilizing either a direct point-to-point drive command or using the cost map to figure out the best route. Whichever type of command is given, the underlying driving is actually handled by the Mobility Open Architecture Simulation and Tools Framework, or MOST. MOST will handle the actual driving of the vehicle as it can utilize onboard sensors the vehicle may carry to avoid any possible obstacles or problems that the vehicle may encounter along the way to its destination. As mentioned previously, the default UI contains a flyout panel on the right-hand side of the map which contains a vehicle status display for all vehicles within the current arena. This display tracks changes in the vehicle's speed, location, status, battery life, and top-down map of the immediate area surrounding the vehicle. The information in this display is gathered by hooking into NML channels which are set up by MOST at runtime. As seen here, the display allows for the user to get a quick update on the vehicle's status and is being continuously updated with the latest information about the vehicle and its surroundings. The primary goal of the 21st Century Systems Agent RCS initiative was to incorporate our use of intelligent agents into the NIST real-time control system hierarchy. We accomplished this by adding an additional level of control above what was previously the highest level of control in the RCS system, the vehicle echelon. The first type of agents we integrated into the system were supervisory type agents, which monitored the movement and location of the vehicles within the arena and watched for certain types of malfunctions or situations that may have arisen. As seen here, when a vehicle is given a waypoint that is impossible to reach, the agents recognize that the vehicle has been stationary for a certain amount of time and fire an alert to the supervisory agents. Those agents in turn determine that the appropriate course of action is to tell the vehicle to move on to the next location on its route. Another type of agent system we added was a type of auctioning system. This system will take multiple AOIs in multiple vehicles and determine which vehicles should search which areas based on the vehicle's shortest path to the AOI and the search radius and speed of that vehicle. These values are all used to compute a bid from each vehicle for each available AOI in the arena. The auctioning system then takes all of these bids and determines the most cost-effective way to assign the vehicle. As seen here, after the system has auctioned off all of the available AOIs, the vehicles are given their commands to search the areas. This brings up the next type of agent in the system, which are our searching agents. The searching agents are responsible for taking an AOI, breaking it up into a searchable grid, and monitoring the status of each grid after a vehicle has been assigned. In this example, you can see a vehicle being assigned to the AOI directly above it. As soon as it is assigned, one of the searching agents breaks up the AOI into searchable areas and tells the vehicle which grid to search first based on its location. Over time, the grids will change color from green to red to show that they have not been searched in a while, alerting the system and the user to this problem. As each grid is searched, its color is returned to a transparent green and the vehicle moves on to the next grid. This process repeats until the entire area has been searched or the vehicle is given a new command.